Welcome back. This is section 10.3. This is about product rule and quotient rule. So product rule is if you have a function f of x times s of x, the derivative of that function is going to be the first function times the derivative of the second function times derivative of the first function. And the quotient rule is if you have two functions, t of x over b of x, the derivative of this whole function is going to be b of x squared, b of x times derivative of the first function times derivative of the quotient function. What do I mean by that? Let's go ahead and take a look. So here I have, let's see what I have here. I have two functions. One is 9x to the power 5 and the other one is x power 4 minus 2. So here, what I'm doing, this is a product, so I will be using the product rule. The product rule is, let me go ahead and show that to you. It's the first function, 9x power 5, times derivative of the second function. Derivative of x power 4 is 4x cubed. Derivative of 2 is 0, so I'm not going to write that. Plus, it's the second function, which is x power 4 minus 2 times derivative of the first function, which is 9 times 5x power 4. Let's simplify this. This is 9x power 5 times, what do I have? Times 4x cubed plus 9 times 5 is 45 x power 4 minus x power 4 minus 2. Now let's go ahead and see if I have that function, which is 9x to the power 5, 4x cubed. Oh, that's not a minus, my bad. It has to be a plus. So let's see which one is that. Definitely not this one. Definitely not this one. My option is option A. Don't get confused like me and pick option D because this is a minus sign right here and it's not a minus, it's a plus. All right, let's go ahead and take a look at the next function or the next problem. Again, I have one function which is 2x to the power 5. I have another function ln x and this is a product. So what do? It's the first function times derivative of the second function is 1 over x plus second function ln x times derivative of the first function, which is 2 times 5 x power 4. When I simplify this, let me change the color. X and x power 5 cancels out and I have 2x power 4 plus 2 times 5 is 10. So I have 10 x power 4 ln x. And let's see if I have anything that matches. Oh, they didn't simplify this one. Oh, yeah, they did. So here I have it. 2x power 4, 10x power 4 plus ln x. So check for the options. This is the non-simplified version, and you have another step where you have to simplify it. Okay, and we have both of those. Now let's go ahead and take a look at the next function or next problem. This is the quotient rule. And again, let me write this down. The quotient rule is I take the denominator and I square it. And I write the denominator on the top. Find the derivative of ln x, which is 1 over x. Instead of a plus sign, now we have a minus sign times the first function, which is ln x, times derivative of 22 plus x, which is 1. And now let's go ahead and see if we can simplify this one. When I simplify this, what do I get? I'm going to simplify this one first so you can see what's happening. This is 22 plus x over x minus ln x over 22 plus x whole square. This is over 1. So I'm going to find the least common denominator of 1 and x, which is x and x. When I simplify this, what do I get? I get a common denominator of x. I have 22 plus x minus x ln x. And again, I'm going to bring down the square which is 22 plus x whole square. Now when I simplify this further, this x gets multiplied with this one, and my final answer would be 22 plus x minus x ln x over x times 22 plus x whole squared. And that's your final answer. So the whole idea is to, let me change the colors here, to write down your denominator, square it, denominator on the top, derivative of the first function, and then derivative of the second function. And then simplify it as needed. All right, let's take a look at the next one. Oh, this is again quotient. So let's see. So here I'm going to go ahead and write this down. Remember what I told you? It's the denominator squared. Very good. I write down the denominator. Derivative of the first function. Again, derivative of log x base 3 is 1 over x ln 3. Simple. So this is 1 over x ln 3. It's a minus. I'm going to extend this one. Times the first function, which is log x base 3 minus derivative of 5x plus x cubed is 3x squared. And now let's see if we can simplify this further. Oops, where's my page? Yeah, right here. Sorry, that's been running around. So let's see if we can simplify this. All right, so I'm going to keep the denominator here. Let me minimize this whole thing. I'm unable to. Let me try one more time. One last time and see if I can have it. Yeah, I can resize it. Let me resize this one, bring it down here. And now I'm going to go ahead and work with this. The goal here is to simplify. So again, I'm going to keep my denominator the way it is. 5 plus x cube whole squared. Let me change the pen style. This looks very weird. And now, as you can see, this part of the numerator, I can simplify that as 5 plus x cube over x ln 3 minus, this is 3x squared. Now, I can write my log x base 3 as ln x over ln 3. That is one of the formulas, one of the formulas of the logs. What do I mean? If you have log a over b, then you can change this to a common log. Let's say c over log b base c. So you can use any base and change the logs. And that's exactly what I'm doing. So I'm rewriting my log x to the base 3 as ln x over ln 3. So I'm going to rewrite this as ln x over ln 3. All right, now let's see what we have. And the common denominator of these two is, as you can see, x is missing. So times, I'm going to use a different color, times x and times x. Keep in mind, you cannot multiply these two x's. That's not how it works. But you can multiply this x with the one in the front. Okay, so now let's go ahead. I'm going to rewrite the denominator, 5 plus x cubed whole squared. I have the common denominator of x ln 3. And now I have 5 plus x cubed on the top minus 3x cubed ln x. And now, so this is one term, so you can differentiate. And now what I'm going to do is I'm going to simplify this further. Like before, the denominator gets multiplied to this one. I'm not going to worry about multiplying the whole thing. I'm just going to rewrite this one. So this is going to be 5. X cubed minus 3x cubed is minus, no, I can't do that, sorry. I thought I can, but I can't because these two are one terms. 5 plus x cube minus 3x cube ln x over x ln 3, 5 plus x cube whole square. And let's see if our answer matches. And there it does. So please be very careful. I made a mistake of combining these two, which like you saw, but I rectified myself. I can't do that because this whole thing is one term. Okay, and again, if you have any questions, pause, rewind, and redo it. But here the concept is I can change my log x to base 3 as ln x over ln 3. So if you have, let me redo it here. If you have log x to the base 5, you can change this to ln x over ln 5. Or if you have log 5 to the base x, this could be ln 5 over ln x. So you can see that the base always comes in the denominator and the one on the top goes in the top. Again, this is recap of the logs that we did in algebra class. All right, so let's go ahead and take a look at the next problem. What do we have here? Here is, when I see problems like this, my first thought process is to go ahead and multiply. So I'm not going to do two different things. I'm just going to go ahead and distribute and then work with them together. So now if I multiply, I get 64 x to the power 1 over 8 plus 8. Remember, when I multiply, I add the powers, plus 64 x to the power 1 over 8. 8 plus 1 over 8 is 64 x to the power 65 over 8 plus 64 x to the power 1 over 8. Now let's go ahead and find the derivative. This becomes simple. So I'm going to find the derivative of this, find the derivative of this, and simply add them together. So this is 64 times, what's the power? 65 over 8 times x to the power 65 over 8 minus 1 plus 64 times 1 over 8 x to the power 1 over 8 minus 1. Now let's go ahead and see if we can simplify this one. So this becomes 520. I plugged that in my calculator. And this, let's see, 65 minus 8, 57 over 8, x to the power 57 over 8, plus this becomes 8, I cancel 64 and 8, 1 over 8 minus 1 is negative 7 over 8. And as you can see, when I have a negative power, I will go ahead and rewrite it. Yes, I know what you're thinking. Why can't you just leave it like this? Again, it depends on your answers. Negative power goes to the denominator, becomes positive. And now, you guessed it right, I have to find the common denominator. So to find the common denominator, I'm going to multiply this. Let me do it here. I'm going to multiply this with x to the power 7 over 8 times x to the power 7 over 8. And let's see what I get. So here I have 520 x to the power. Remember what I do? I add the powers. 57 over 8 plus 7 over 8 plus 8, the whole thing divided by x to the power 7 over 8. Now if I recap, 57 plus 7 is 64. 64 over 8 is 8. So I end up with 520 x to the power 8 plus 8 over x to the power 7 over 8. Final answer. So the trick here is to not to have any negative powers. So you bring it down, find the common denominator, simplify it further as needed. Again, pause, retrack if you have any questions, and then move on to the next one. Let's see what we have here. Again, quotient. Remember what the quotient is? I square the denominator. I plug the denominator. Find the derivative of 24. Okay, before I do that, Instead of writing 24x cubed, I will rewrite this as 24x to the power 1/3. So that way I know it's 24 times 1/3 x to the power 1/3 minus 1 minus the derivative of the denominator x squared, which is 2x because derivative of 4 is a constant, times 24 x to the power 1/3. I'm going to keep it as 1/3. You're going to see why in a second. So now I'm going to go ahead and simplify this. 24 and 3 cancel each other. So I have x squared minus 4 times 8. And x to the power 1/3 minus 1 is negative 2/3 minus this is 42 x. 1 plus 1/3 is, what is 1 plus 1/3? This is 4/3. I blacked out for a second. And this is x squared minus 4 whole squared. You know where I got the 1 plus 1/3, right? This is 1 and this is 1/3. So when I multiply, I add the powers. Just making sure. And now I see a negative power. The moment I see a negative power, I know I cannot work with it. So what I'm going to do is x squared minus 4 over 8. I'm going to bring this down all the way to the bottom and make it positive minus 42 x to the power 4/3 over 1. And the whole thing divided by, don't forget the denominator, keep bringing it down. I know it's annoying, but you have to. And now when I have to subtract, I have to find the common denominator. So what do? Times x to the power 2/3 on the bottom times x to the power 2/3 on the top. And now see the magic. Dun, dun, dun. The denominator stays x squared minus 4 squared. I'm going to multiply the 8 and 8. So I have 8 x squared minus 8 times 4 is 32. Yeah. Minus 4/3 plus 2/3 is 6/3, which is 2. So this is 42 x squared. Did I do that right? Yeah, minus 42x squared. So when I simplify, oh, wait a minute. Where did I get 42 from? This is 24 times 2 is 48. I'm sorry, 24 times 2 is, this is 48, this is 48. No wonder I'm thinking, where did I get the 42 from? So this is 24 times, everything stays the same except this becomes a 48, this becomes a 48. And now this also becomes a 48. Okay, so only thing that changed is the multiplication. Everything stays the same. Now I have x squared, 8x squared minus 32 minus 48x squared. And when I simplify this further, I have negative, the whole thing